Okay, so yeah, the title of my talk is Full Stack Development with Bazel, Angular, and Other Friends. I'll quickly introduce myself. I work at Narwhal in New York City. Some of you may be familiar with some of our products. We create NX, which is a set of extensions on top of the Angular CLI. More recently, we published Angular Console, which is a UI for the Angular CLI. But we also do a fair amount of Angular consulting. And if you have any questions, feel free to catch me after the talk. I'll be happy to talk about NX, Narwhal, Bazel, anything else that you might wonder about. My Twitter is @Helgevold. And all right. So out of curiosity, how many here have actually heard of Bazel? So most of you will actually believe anything I say then, right? Okay, so that's good, but I don't assume any prior knowledge of Bazel, so that's okay. There are basically two Bazel topics I'd like to cover today. First one is build performance from doing incremental builds and remote build execution and caching. The other part is full stack development using Bazel as the single tool chain for building your front end and your back end. And the nice benefit you get from that is the ability to share types between completely different languages. And I'll show you an example where we share types between Java and TypeScript. So, but first of all, let's answer the question, what is Bazel? Bazel is the open source version of Google's internal build system called Blaze. It's specifically designed to build applications at scale. And some key features are the ability to build large projects, like thousands of files. But at the same time, avoid the kind of the linear slowdown of your builds as the project grows. And it's also a language agnostic build tool, so you can use it as the single build tool for the entire tech stack. And you might wonder, why do we need this? Because I remember the good old days where all you did was just write some plain JavaScript, you ran it directly in the browser, and that was it, right? But times have changed. Now we have Angular, and no one really writes Angular in the native runtime language. You always go via some sort of build-time language. Instead of JavaScript, you write TypeScript. Instead of CSS, you write Sass or less. And most people agree on the benefits of TypeScript, but there's a potential impact to build performance as the project grows. So you can, at some point, you might notice like slow compilation times, which leads to a slow dev experience. So how can we ensure fast builds even as the project grows huge? So Bazel is designed to do what's called incremental builds. And incremental here means for every code change, you only rebuild the code that actually changed or depends on the change. And as a result, the build time is proportional to the change. So single file changes will be super fast. And that works well in the dev workflow because typically what you do is you touch a file and you hit save, right? So it's important that that build is fast, even as the project grows huge. And being incremental is key to Bazel's build performance because non-incremental builds will typically have a linear slowdown as the project grows because the more files you bring in, if you're building everything every time, that's at some point will be too slow. So how do you make the build incremental? Bazel requires us to define a build graph, and the graph determines the granularity of the rebuilds. And each node in the graph is a buildable unit, basically one or more files that are built together. So before building, Bazel will check to see if there are changes to any of the input files, and if there are no changes, it doesn't have to rebuild that code. And the size of a unit is user defined, but the fewer files in the unit, the smaller the rebuild penalty will be. In Angular, the smallest build unit is an ng module. So that means that your rebuilds can be as small as a single ng module. And so far, we've kind of just talked about building software as something generic, but how do you actually define the specifics of what goes into your build pipeline? And in Bazel, you use what's called Bazel rules to define the specifics of each build step. And some examples are the Angular AOT compilation, Sass compilation, and bundling of JS files. And internally in these rules, you execute what's called actions. And these actions typically wrap some existing binaries like the AOT compiler, uglify, rollup, svelte, anything. Like it's you can build your own rules. So basically, it can do anything you want it to do. And the rules can also be chained to form a pipeline. So the output of the AOT rule can be the input to the bundling rule. So it basically forms the entire build pipeline. And so where do we define these rules? The rules are defined in special build.bazel files. And it's currently a manual process to maintain these files. But in the future, we'll probably have tooling that will handle that, like to basically, based on imports in the source code, it will generate these files for us, because this is another manual step that would be nice if we can automate away. So let's take a look at a build.bazel file. So in this case, I'm showing you two Bazel rules. The first one is SAS binary, which essentially takes a SAS file and converts it to CSS. And the other one is the ng module rule, which is what we use to AOT compile Angular ng modules. And the ng module rule is a little bit more interesting. Instead of a single file, like the case of the SAS binary, you glob for a bunch of TS files. And you also declare a dependency on the SAS binary rule, because the components in the ng module depends on the CSS produced by the SAS binary rule. And you can specify a TS and config, and then there's a depths array, which is, because since ng modules can depend on other ng modules, you can declare a dependency on other ng modules by declaring their ng module in the depths array. And at the top, we're basically just importing the symbols that we use. Like here, you're importing the ng module rule, and this here is the SAS binary rule. And rule execution ties directly in with incremental builds, because Bazel will only execute the rules if the input to them change, or the output is needed by something. And Bazel comes with built-in support for checking if the input files change. You don't have to write anything custom for that. So, but where do these rules come from? You can define your own local rules, like you can write your own rules, and if you do that, it's the language that you write them in is called Starlark, which is a variant of Python. But for most common things, you can just bring in the rules from external repos. There's a lot of rules out there that you can use, and you can, if you write some local rules, you can basically submit them back to the open source community. It works like any other open source project, and but for most things, you don't have to write your own rules. Like you have all the typical things, like in the case of Angular, like AOT compilation, bundling, CSS, most of the things that you would need, you already have. And the external dependencies are declared in a special workspace file. And you can kind of think of the workspace file as a Bazel equivalent of the package.json file in the NPM world. And here's an example. Here's a snapshot of a workspace file. This is what's called a Bazel workspace rule, which is meant to bring in external dependencies. In this case, I'm bringing in the SAS rule that I showed you previously. So this is basically pointing to the URL where this thing is hosted, and then Bazel will pull it in so that you can use it in your own build files. But you can also bring in Angular itself as a Bazel package, because now that the Angular team has started using Bazel for their development, you can now depend on Angular via Bazel. Instead of doing npm and package.json, you can now stick another HTTP archive rule in your workspace file and bring in all the source of Angular. So this is optional. You can still do regular npm if you prefer that. This is just another option. So, all right, we talked a lot about, oops, okay. We talked a lot about incremental builds and how that's important to Bazel to ensure fast builds. But what about the first build? How can you make sure that the first build is fast? Sorry, because when you're doing a build for the first time, there's no previous incremental build to lean on, right? There's the increment is the entire source code. So how can you make sure that that is fast? Because by default, Bazel will not be any faster than a non-incremental build in that scenario, and that might be disappointing to some of you, but luckily there's a way to get around that, or at least mitigate the slowness of the first build. So I want to talk about something called remote build execution. And basically what that means is you outsource the build to builders running on different servers. So you can run on many remote build workers instead of a single local builder. And that means you can run on like hundreds of core, like 500 plus, instead of the 4 plus local cores that you typically have on your developer machine, right? And this can be orders of magnitude faster. And so you have a few options when it comes to hosting this. You can do a self-hosted version. If you have your own hardware, you can stand up a self-hosted solution. Build Farm is one example of that. I have a link to their GitHub, so you can pull it down from there. But another option is to do a cloud service like Google Cloud or something like that. And remote build execution is supported out of the box, but it's important to keep in mind that when you're actually building your software on a remote machine, you have to make sure that everything, like that you don't have any local dependencies that won't exist on the remote machine. Because if you start pointing to local file paths, like involving your own user directory or something like that, that's not going to exist on the remote machine. So it's very important that you tell Bazel about all your inputs and don't have any surprises that Bazel won't be able to handle on the remote machine. And in addition to remote execution, we have remote caching. So when you're building locally, you cache to the file system, but we could instead write to a remote cache, and that way the cache can be shared by everyone. And you have two options. You can combine remote caching with remote execution, which means that the remote workers will cache and share a cache. But you can also do it without remote execution. You can build locally, but check the cache before building. And a typical scenario for this is you can use your CI server to seed the cache, because it typically builds every commit anyway, so it should have a fairly up-to-date cache. And it's cheaper than paying for a remote build farm, and you can have tremendous benefit from remote caching. It can really speed up your build. So if a developer comes in and tries to build the source code for the first time, if the developer can pull from the cache, then the build can be much faster. But it really depends on a fast network, though, because if you're trying to pull from a remote cache and your network is slow, then the network latency will negate any benefit that the cache will give you. But as long as you can have a fast network, it will have a very good effect on performance. Okay, so for the second part of my talk, I would like to focus on full stack development. And to me, this is probably the most exciting part about Bazel, because I really like the parts about incremental and fast builds, but that may or may not be a problem that you have. Like if you have if your existing build tooling can provide you it can already provide you a fast build, there's no point in switching out your old build stack for that reason, right? But in one area where I feel like Bazel adds a lot of value is this whole full stack thing, because Bazel is not tied to a specific language. You can support any language as long as there are Bazel rules for it. And that enables you to use Bazel as the single build tool chain for the entire tech stack, and which effectively means the same tool for front end and back end. And several popular languages are already supported: Java, C++, TypeScript, just to mention a few. And TypeScript is not just Angular. Like you could have had an Express API written in TypeScript, and anything written in TypeScript can be covered by this, basically. And the benefit is not just about fewer tools, because the best benefit is that Bazel enables us to share types between different languages. And in my example, I'll show a Java backend and an Angular frontend. Because a typical example I think most front-end developers have seen is that their front end falls out of sync with the back end, right? The API payload is no longer matching the expectations on the front end. And if you don't have shared types, you won't find these issues until you actually run the application. But if we can share the types through the build system, then we can catch these inconsistencies at build time instead, which eliminates that whole category of bugs, basically. And so how can we do that? Like, obviously, you can't share types directly between Java and TypeScript because those are not compatible languages, right? But what we can do is we can use this concept called protocol buffers, which essentially is a way to define a schema that describes application objects. And you then have Bazel rules for transforming the schema into language-specific types. So the input is the schema, and the output is language-specific code. And like I mentioned earlier, I'll show you an example with TypeScript and Java. And here's an example of a protocol buffer schema. So the syntax is basically you define a message, give it a name, and then you enumerate the properties and give the properties types. And don't worry too much about this number. This is basically just used internally for serialization. So for every property, just increment that number by 1. So let's look at an interface that was generated from that prototype. So this is the case. This is the TypeScript case, right? You have an interface generated off of that schema, and this iCar interface represents the payload from an API, like a car API. But the important part is that this was not a hand-coded interface, because in my opinion, front-end devs should never maintain a separate version of what the API response should look like. It has to be generated from the source, because if you're creating your own interfaces just to kind of mimic what you think or what the API payload used to be, then you're basically not providing a lot of value. You have types, but it's not really reflective of, like, it's not necessarily reflective of the actual API response. Like it will quickly fall out of sync because you're manually maintaining it. So how do we generate these? We basically just use another Bazel rule called proto library, and it just takes the proto file, like this file here is the car.proto file, which is where the car message is defined. And then you feed it into the proto library, and this basically becomes a base rule that you can feed into other language-specific rules. So you can feed this into a Java-specific rule and or a TypeScript-specific rule or a C++ specific rule. And the point is that the generated code is always generated from the same source, so it will always be in sync, and it happens at build time. So you won't have a case where the front end and the back end fall out of sync anymore, because if they do, there'll be a compilation error. And here are the language-specific rules. So in this case, we have the TS proto library to take the base rule for the car proto rule, and then the output of this would be the iCar interface, plus a few other things, but that's one of the more useful things. The interfaces are very easy to use in your code. Like there's a few other there's also a car class generated, but I generally only use the interface part because I only care about the typing, especially for this API use case, because it's really the main point when I use this is to make sure that my front end knows what the types look like on the back end. And then in the Java version, you get a slightly different output. You get these like Java builder classes, and I can show you in the source code in a minute what that looks like. So let's take a look at an example. So I have this demo component project that I built. I'm using Bazel to build the whole thing, and I have code in Angular, React, something called Svelte, Node, Express, and Java. And I have a link to it here if you're interested in looking at it. And so let's just take a look. Bring up. Are you able to see the console here and the code, or is it too small? Okay. Let's see. Did that help? Great. Okay. So I'll show you the UI. The UI is not pretty, but it does the job. So I have this car feature here. I'm using the simple UI. When I click a link here, you trigger some requests to get some car information, in this case about Lamborghinis. And the API looks like this. You got the name of the car, a key, and then the top speed. And right now, my UI depends on this response. Like the properties have to be named exactly this for this to work. So if someone were to change, like let's say make top speed all lowercase, that would break my app. And if I didn't have type checking between the back end and the front end, I wouldn't know until runtime, or like I would not know until I actually try the application. So let's look at how this would function in Bazel. So we're back to the message here, the message car, and here I'm running my dev server. Try to make this as big as possible. So let's say I go in. So I go in and change my schema now. I say, okay, for some reason I want all my properties to be lowercase. Hit save. And then it starts building. And now, notice there are compilation errors because now Bazel has told me that if you want to make this change, here are all the places in the source code that you have to update. So I have 2 places now. I have the Java servlet, which basically is the API for this. And notice here, if you compare this to this is the Java builder code that I talked about. This is generated from the protocol buffer. So when I ran that Java specific rule, this is what I got. I got this car class with these builder methods. And notice these methods are basically named based on the schema. So they're basically derived off of these. So since I now changed it here, it's going to tell me, okay, this is no longer good because this assumes the uppercase spelling of speed, right? Same with the TypeScript case. It's going to, if I can scroll to that, running both in here now. So it's saying the property top speed does not exist on iCar. Did you mean top speed? So it's even helping me figure out what the correct thing is. So if you look in the TypeScript code here, I have a dependency on iCar directly, and it's saying, okay, for this to work, I need this to be top speed. So then you either then change it everywhere, or you just revert it back, saying, okay, this was not a good idea after all. And then you just hit save, and it goes back, and it's done. So this is my favorite feature, that you can keep this, that you can basically benefit from typing beyond just TypeScript in your front-end code. So I think this is probably, to me, the most important reason to consider Bazel as your build chain. So, and now it's working. Let's try it. And it's working again. Well, there you have it. I think that was all the material I had today. So feel free to ask me any questions. If you're interested in Bazel or any of the narwhal stuff, I'll be happy to try to answer or talk to someone who will know how to answer.